Okay, so let's get writing our own merge sort. So I have a new snippet again. I have our merge function that works from 2 videos ago. We can get rid of this line for now. Now I'll define our merge sort function, which takes a single array. And if we go back to our pseudocode, all that we want to do is keep splitting it up into smaller arrays and calling merge sort on those arrays until the length of the array is 1 or 0. So we can start with the base case if we want. If array.length is less than or equal to 1, we're going to return the array. Not array1, array. So right now, that doesn't mean much. Basically, we're not doing any recursive calls. Remember, every recursive function has a base case and then the recursive case, the recursive function call. So we're going to call merge sort on something again. But it needs to be on the 2 halves of the array. So how do we split this array in half? So for example, if I call merge sort down here on this array, 10, 24, 76, 73, 72, and 1. So how do we split this in half? So if we just took this, I recommended using slice. So if I save this to a variable, var arr equals that. How do we splice it or slice it in half? Well, we go from 0 for the left side. We go from 0 until what? How do we find the midpoint? Well, we could take the array.length divided by 2 and then floor that. All right, so remember binary search, we did the same thing. So that's what I would do. I would do math.floor of array.length divided by 2. And that gives us 3. So then I would do array.slice from 0 to 3. And that gives us the first 3 items. And then we need to do array.slice from 3 to what? We need to do we can actually just do array.slice 3, and it will go from 3 until the end. That's how it works. We don't have to pass in the second number if we don't want to. So that will split the array. That's our first step. And then we'll call merge sort on each of those. So let's just write that code to start. So we can define the midpoint here. So let midpoint, or let's just call it mid, equal math.floor, just the same thing we saw, array.length divided by 2. So that gives us the halfway point. Then we're going to say the left side equals array.slice from 0 until the midpoint. And then we'll say the right side equals what? The right side is going to be array.slice just from midpoint until the end. So now we've split that array into 2 pieces. I'm missing an R here. There we go. Now comes the tricky part. Instead of just doing left equals array.slice, I'm actually going to call merge sort array.slice. And same thing here, merge sort array.slice until the end. Okay, so what's happening here? If we called this the first time through with this array, array.length is not less than or equal to 1, so we skip that. We find the midpoint, then we find left and right. So if we focus on left, we're calling merge sort again on this array that you can see right here. So that goes through, and it's called again. Array.length is not less than or equal to 1, so we skip that line, and then we split it in half again, and now we call merge sort on the left and right. And then one time through, one of them has length of 1, so we return that array, but the other one has length of 2 because there's 3 items, so we call merge sort again. And then at that point we have 3 single item arrays. And now we have to worry about merging them back. And this is the other bit of magic. We merge the left and the right. So this is the code, and I'm going to walk through line by line how it works. We're going to step through the call stack with a smaller version, but let's just make sure that it's working. So if I execute it, it looks good. 1, 9, 10, 24, 72, 73, 76. Okay, now let's call it on, let's do 4 items. And I'm going to put a breakpoint right here. Now if we look at what happens just with these 4 items, I'm going to step through it. So I'm going to run the code. And let me close the console so we have more space. Look at our call stack over here. Okay, here we go on our journey. So we start, and merge sort is called on this array. It's 4 items long, so this first thing does not happen. Then we find the midpoint, which is 2. Now here's the first thing. Watch what happens to our call stack. We are recursively adding, so there's another merge sort that's been added to the call stack. And if you look now at this merge sort, it's been called on that left half, right? So that left half is just 10 and 24. Is the array.length less than or equal to 1? Nope. So we skip it. And what happens again? We find the new midpoint, which is just the middle of this array. We're calling merge sort on what? If we look at our stack again, there we go. We're calling merge sort on a single element, 10. All right, now, this time array.length is less than or equal to 1, right? So we're going to return the array of 10, and you'll see it pop off the stack here in just a second. Return value, array, and it popped. Next, we're back to this one. So now we're back to, we left off right here, right? This is a hard thing about recursion. I wish I had a whiteboard diagram this all out, but we were waiting. This function call waited for left to go all the way until it returned something, and now right needs to go all the way until it returns something. So right on that second half is 10, 24. We split it, and the right side goes in, and we get the array of 24. Array.length is less than or equal to 1. So we return array, and you'll see it pops off the call stack in just a second. Now we merge the left and right, 10 and 24. And when we merge them together, it calls merge. All this code happens, and at the end of the day, we end up merging and then finally returning. And watch the call stack. Now we pop off again. Now this time we finished left, right? That was waiting. In this code, we were waiting to merge the left side. Now we need to do the right side. We never even ran this line. So now the right side is now going to go. And if we take a look, it's calling merge sort again with, what is it passing in? Just a moment. There we go, 76 and 73. So array.length was not less than or equal to 1, so we didn't return it, so we move on. Now we call merge sort on the left side, which gives us 76. The array.length is less than or equal to 1, so we're going to return array, and you'll see it pop off that call stack. Keep going. There we go. And now we're back here at merge sort for the right side. It's crazy, I know. This is the hard part to understand, but we're back here, and this time, we're calling it with 73, array.length less than or equal to 1. That's true. We return that array, which is 73, pops off the call stack. Now what we have is left and right. So left is 76, right is the array 73. We merge them together, so we call back up here, go through this, merge them, and then eventually we return results, which is the merged array. And now we return that from this merge sort call to our original call of merge sort, which was waiting. So we have left and right that have now been merged. Well, they haven't been merged together, excuse me. They have been sorted, they've been split up and sorted individually and then merged. And now we have two arrays that are 2 items long, and we merge those together with our final merge, left and right. So now this code takes a bit longer because we've got 2 pieces of data for each one. But you can see results down here. We return results to merge sort. So now we have 10, 24, 76, 73, and that is what we return out. And finally, I think if I show the console, we end up with that return value. Whew. So as you can see, it's a lot to keep track of in your own, just 4 elements, trying to keep track of it all in your head can be a lot. So I diagrammed it out, and let's just take a look at the actual order things happen in. So when we call merge sort on 10, 24, 76, 73, first thing that happens, array is this array. We check, is the length less than or equal to 1? No. So we find the middle point, and then we call merge sort on the left side from 0 until the midpoint. So this is called merge sort of 10, 24. So then in that code, if our list is 10, 24, it's still not less than or equal to 1, the length. So then we call merge sort again on the left. And now, this time, the length of this array is less than or equal to 1. And in that event, we return array. So we return 10. So now this merge sort of 10, 24 the list of 2 items long, it now has a value for left. So next, it finds the value for right. It was waiting for this to come back, remember? Now it came back, so it moves on to the next line, right. So now we call merge sort of the right side, which is 24. Merge sort of 24, the length of that array is less than or equal to 1, so it returns 24. So now we have our left and we have our right. So now we can move on to this line, merge left comma right. So when we call merge left comma right with 10 and 24, remember our merge function takes the 2 sorted arrays, it merges them, and that returns a value, which is the array 10, 24. Yes, it was already sorted, but ignore that part. Our code doesn't know that. So it returns a value now. So that was returned from this merge sort call, which was the left side of our first merge sort. So now our very first merge sort was waiting, and it has a left side returned. Now it's going to do the whole right side. So we call merge sort on 76, 73. In that code, the length is not less than or equal to 1, so it computes the midpoint, and then it does the left side merge sort of 76, which that is a 1 item array, so it returns the value 76. Then this right side, which was waiting, we completed this side. Now we're going to merge sort the rest, and that gives us 73 as a return value because it's a single item array. Then once again, we move on to this line. This was waiting, merge left and right. Well, now we have our left and our right, so we merge them, and that returns 73, 76, 2 item array. Then this merge sort up here now has the left and the right that it was waiting on. So it got this, then eventually this. Now it can actually merge left and right. And to do the left and right merge, we end up with this, 10, 24, 73, and 76. I know it's a lot, but remember, I've said this a couple times, just focus on being able to explain what's happening or walk through. If you have a whiteboard or a piece of paper, I think it can be really helpful to write down exactly what's in the call stack at any given point. And I recommend you don't try it on a super long array. If you go into like 6, 7 items, it takes a lot more time and a lot more space to diagram. Please don't feel too intimidated by this. In the next video, we'll talk about the big O of merge sort.